The data visualization pre-survey should be available in the chat now. Thanks, Jessica.
You're welcome.
For those of you who just joined, we are taking a few moments to complete the data visualization pre-survey before we get started. The link is in the chat. All right, so it is 1:35, so let's carry on with our discussion of data visualization. So similar to the data analytics lecture, we'll start with an outline, a few slides about data visualization and its importance and the different types of charts that you can make, which the answer is virtually endless. And then we'll end with a couple of data visualization exercises to just give you a taste of what's possible um, in Python. Okay, so data visualization is a field in data analysis that deals with visual representation of data. That's pretty straightforward. Hopefully, you kind of had that understanding already. It's just when we take all of our data and visualize it in some way that adds value to the analysis. So just similar to how data analytics can be really useful for taking a whole bunch of data and giving us a number that or a series of numbers that pretty easily conveys, the sort of underlying trend of the data or of the phenomenon, what's happening. Data visualization can similarly be extremely useful for helping us to understand what is going on with our data, especially in instances where maybe the mean isn't representative or something, if the data is really, really spread out or something like that. So it's useful to when you're examining your data to not only calculate the very basic descriptive statistics, but also to look at your data visually to help you, see the trends and see what types of analysis might be appropriate with it. Um, so data visualization deals with plotting the data in an effective way to communicate inferences from the data to communicate, the main points that you want to show with your data. It plays a significant role in both small and large data sets, but it's especially useful for large data sets, which would be, nearly impossible to, not nearly, it would be impossible to parse, many thousands of data points without having a way to visualize the trends in the data. So data visualization provides a visual summary of our data, and it also it's important for the human mind because the human mind is much better at looking at pictures and maps to understand what's going on in the data as opposed to just lists of numbers or even words in that sense. So Python offers many plotting libraries that are specific to which type of plot you're going to be using in a lot of cases. So some of probably the most popular Python library for plotting is matplotlib. We've used it a number of times so far just as a basic plotting tool. Seaborn is built on matplotlib. So matplotlib is the basics, kind of the basic plotter, but Seaborn makes all of your plots look pretty. Visually appealing plots is what Seaborn does. So the default settings in Seaborn is basically to take a matplotlib figure and add some flair to it, if you will. Bokeh and Plotly are two other libraries that are really good for creating interactive data visualizations. So if you wanted to allow, post your figures online and allow your viewers to interact with your figure to see different trends in the data or look at specific data points, they could do that, or you could do that through Bokeh and or Plotly. And these libraries allow you to create really informative and customized plots to present data in the most simple and effective way, which is a skill that you will learn over time if you stick in the field. So we'll go through now a number of different charts. These are kind of your most basic charts, and we'll look at yeah, just some examples, and in the end, we'll talk about how to create them in Python. So the most basic of plots that you've probably known for many years now is just a simple line chart or a line graph. It's used to visualize the values of something over a specified period of time. So it's not always tied to time. It can be any continuous x value, basically. And this shows, for example, this line plot shows the total units of company sales of product A, B, and C um, from 2012 to 2019. And so this is really easy for you to see if one line represents product A, one line product D, one line product C. It's really easy to see that product C is the most successful product overall, followed by product A, and product B is the least successful. So this is an example from business, but you could make line charts, line graphs to show perhaps building energy use change over time or something like that. Lots of different applications. So next we have scatter plots. Scatter plots are very similar to line plots, except for without the line. It's a way to represent the relationship between two variables. So this can be x on any value of x on the x-axis as long as it's a numerical value, and then any numerical value on the y-axis. So usually when there's a relationship between the two variables, the x variable is your independent variable and the y value is the dependent variable. So when you are plotting, thinking about how to make your plots, your independent variable always goes on your x-axis. Sometimes it's a little bit hard to identify, but you'll get better at it over time. And so when you're talking about the types of plots that we create in water resources and in energy and in civil engineering, a lot of times your x-axis is going to be something like distance or time or something that you are measuring your y value against, basically. Um, Sometimes you do have scatter plots where there is no relationship between the two variables at all, and you would see that pretty clearly once you created the figure that there was no correlation. So if you have a figure where you've plotted two variables, one on the x-axis, one on the y-axis, and there is no correlation between the two whatsoever, what do you think it looks like? If we had no correlation between our variables, instead of this nice straight line that we have here, what would it look like? What do you think? Just points on a graph. So yes, but these are also just points on a graph, right? Um, what would be the shape of those points, if you will? And don't say circles, because that's just dependent upon the marker that you choose. So these points on this graph are in a pretty nice straight, fairly straight-ish line, right? Because there is a correlation between online advertising dollars and e-commerce sales. So if there was no correlation whatsoever, so if I was looking at stream flow in Cuba versus stream flow um, at a site in I don't know, Tanzania, sure, two random places that would have no reason to have correlation between them. What do you think that plot would look like?
The points could be scattered on the plot, like um, with no rhyme or reason.
Yes, exactly. Thanks, Joel, for speaking up. But yes, you are right that the points would be scattered all over the place with no rhyme or reason. So like I said, this is a pretty nice straight line here, but if there was no correlation, we might have points all over the place and it just looks like a cloud of points basically, with no easy way to see or no clear trend in them. If you were to, you could do a linear regression on a data set without any correlation, you would get an equation, but in this case, you would have a really low R squared value. Okay, so another type of chart, which you probably are already familiar with, is a bar chart. A bar chart or a bar graph represents data using bars of different heights. You sometimes have vertical bar charts, or you have horizontal bar charts where the bars are laid horizontally. This is more representation. It's called a bar chart, but it's these are columns, whereas bars are the horizontal ones, horizontal lines. So with these types of charts, it's really easy to see the comparison between the data. In a lot of cases, bar charts are for categorical data. So in this case, we have a list of percentages of sales made by different sort of divisions in a company or yeah, so you can see that electronics is the lowest performing and heating is the highest performing. So it's really easy to see in this case what that relationship is. And then we have a bunch in the middle. So bar charts are super easy for us to process. Very similar visually at least as a histogram. So histograms are like I said, similar to bar charts where we have On the x-axis, any type of, it can be categorical, it can be numerical, basically, but then we have frequency, or a value related to frequency on the y-axis. So in this case, we have the score on the final exam versus number of students. So we have, for example, approximately 40 students received a value on their final, or a score on their final exam, between 60 and 80, right? And so with the histogram, you're essentially showing statistical information, because if we were also to plot the distribution of this, of the students and their scores on their final exams, the distribution would follow, more or less the shape of this histogram. And so you can see from this that the histogram is not, of scores, is not really normal, right? We talked about that. It's skewed a little bit to the right. Um, and so that's one of the things that you can see with a histogram. So we're looking at successive numerical intervals of equal size, and the data is usually colored rectangles or shaded rectangles of variable area. So the smaller the rectangle, the lower the frequency, basically. So they look visually very similar to bar graphs, but they're different, because you will never see a histogram with gaps between the bars, which you don't see that, in this case, hardly. These are very narrow gaps. But with histograms, they're always going to be adjacent. And then with histograms, the y-axis is always going to be some measure of frequency, whether that's a fraction or the number of students, or a count or something like that. Okay, so the next chart, which is, I would say, less common, um, generally in engineering overall, or but might be more common in some areas of the sciences if you're looking at like species counts or something. But we have a pie chart. So a pie chart is a circular plot that uses pie slices essentially to display the relative sizes of the data. It's a great type of chart if you need to display the percentages of the whole, right? So all of these percentages will add up to 100, and it's really easy to visually say that 40% of web traffic sources came from searches for this website that this chart was made for. And it's just very easy for the human mind to digest. So if you have percentages of data types, or data, any sort of variable that adds up to 100, you can make a pie chart, and it'll be pretty easy to convey what you're thinking or what you're looking at. So the next type of chart is a box plot. Um, Box plots are also called box and whisker plots. That might be the way you learned about it in school, but it is used to uses boxes, right, and essentially lines or whiskers to depict the distributions of one or more groups of numerical data. So the construction of the box plot is based around the dataset's quartiles. So when we're looking at this black line in the middle here is the mean, the average, and then we have the kind of the split between the first quartile and the second quartile is right here, and then the split between the third quartile and the fourth quartile is right here. And so this kind of shows you whether your data is normally distributed or is skewed in any way, or not. So if we had normally distributed data, the box plot or box and whisker plot would be symmetrical, right? So in this case, we don't. We have um, more data, like skewed farther out on this side, right? So that shows us that our mean is kind of shifted to the left in this case, right? So with box and whisker plots, you show kind of the normal limits of the data, but then outliers are usually identified as well as separate points on the outside of the whiskers. So these are outliers in this case. So we've talked a little bit about quartiles, but I don't know that we've clearly defined it for you. So if we're talking about the first quartile, we're talking about the kind of the split in the data where 25% of the data is smaller than this value that we're calling the split between the first and second quartile, and 75% is greater than. With 20 of the second quartile, we're talking about the 50% mark, where 50% is smaller, 50% is bigger. Quartile 3, we're talking about the 75% mark, where 75% is lower and 25% is higher. And then we don't really have a quartile 4 that we talk about because that's just all of the data is less, which is not particularly useful. Especially you can just talk about it in terms of the max. That'll convey the message clear enough. The next type of chart is, I would say, kind of like the new and improved box and whisker plot that modern technology has enabled. But this is a pretty popular chart these days. It's called a violin plot because it's vaguely shaped like a violin, but it's essentially a box and whisker plot, which you can see in the middle here. We have a box here and the whiskers here, and you see the mean or the median here, depending on how you choose to make the figure. Um, and it's pretty useful and popular because these lines on the outside, they show you the distribution of the data essentially, right? So this is almost like a distribution, probability distribution laid on top of a box and whisker plot. So you can see that most of the data is concentrated in this area. And then we have the data tailing off on either side. It's skewed a little bit to, in this case, to the, if we're looking at it from this side, to the right or to the bottom. And then we have a little bit of a hump in our data over here. So you can see that it's not perfectly normal, that there's some shape to this distribution curve. So there's a couple different things that you can see in your violin plot. So it's a really easy way to visualize the distribution of numerical data. Okay, so before we go on, any questions on these different types of charts that you can make in Python? Has anybody heard of a violin plot before? You had not? Yeah, lots of people have not. Like I said, it's kind of the new cool plot, if you will. It's kind of funny, but we'll learn how to make it. And there's in Python a lot of options you can change in it to make it look differently to suit your needs. We won't talk about all of them, but we'll just introduce the concept. Okay. So, these are what I've showed you so far are the very basic plots. But I just wanted to show you this slide in particular, and there's one that follows, that usually the slides that you will produce, the figures that you'll produce for your final research papers, research presentations, etc., will be a combination of multiple lines and multiple information, sometimes multiple types of plots, because when you're talking about presenting your research data, you usually don't have a lot of space to have a separate plot for sort of every finding. So you try to find creative ways to combine a bunch of information into a single figure so that people can get a really good snapshot of what you're trying to convey in one picture, basically, because it not only helps, doesn't take up as much space, but it also just helps your reader, helps your viewer understand what's going on much more easily. So they don't have to like flip back and try to compare different data, different figures and figure out which is higher, which is lower, what's going on. You try to present it in a way that has as much information as possible to tell as much of the story that you want to tell in in one figure. So for this example here on the left, this is from um, surface temperature data taken by a drone for different types of land use, right? So we have the purple or blue-ish color is from an industrial area. The red is from a park area. Green is from a low-cost residential area. And then a yellow was from a high-cost and expensive residential area. So you can see, and this is how the surface temperature in these areas changed over time. So we have the kind of the average with a solid line here, but then we have the range of the values in kind of the shaded plot. So you can make a lot of different types of plots that convey a lot of information in one figure. So if you didn't know any of this information, you could look at this and say, for example, like, the temperature starts really low and increases throughout the day. You could say that the industrial area has the largest range of surface temperature values. The park area with this red has the smallest range of surface temperature values. We have that the residential high cost um, community actually has the highest average temperature throughout the day, essentially. Um, and that the park area has is the coolest in the morning, but then as it kind of heats up throughout the day, it actually is warmer than the industrial area. So this plot has a lot of information in it that you can derive from it. Whereas if we just had one line on one plot, it would be really hard to kind of make those types of comparisons. Um, Similarly, on the right here, we have a series of linear regressions for different cities, for rainfall in different cities, right? So you have the raw data as the scatter plot with the lines connected, and then you have the black line, solid lines showing the linear regression. And then you have on here also the, what was I gonna say? Oh, the equation and the R-squared value. The equation with the slope and the intercept, and then the R-squared value to show the goodness of fit. So, like I said, a lot of times we are creating more complex figures when we're talking about our research, because then we can convey the story a little bit better with multiple pieces of data um, on them, on the figures. So here is another example of multiple pieces of information on a figure. This is also another surface temperature data on the x-axis versus albedo on the y-axis for different types of land covers. So, or land uses. So we have, canopy cover, shrub, mulch, parking lot, sidewalk, roads, um, different types of surfaces, composite and rubber surfaces, and then also grass. So you can see from this figure very easily how much um, albedo is changing with temperature for different land uses, right? Um, and this is a scatter plot that just has a lot of additional information packed into it than just showing one of these data points on here. So on the right here, we have another um, figure that has some drone data on it. So taken by surface temperature taken by a drone versus surface temperature taken by a by a satellite, Landsat. So you can compare those really easily, one to one. And then we also have a profile line on here from A to A showing the drone temperature, what the drone captured of the temperature, and then what the Landsat captured for the temperature as the solid black line here. So again, another instance where for one paper and a figure, we're combining multiple figures and multiple types of figures to try to convey the story as clearly as we can. So in this case, the story pretty much was, the high resolution of the drone allows you to see much more detail in the surface temperature variation than Landsat does. Okay, any questions on these this kind of discussion about creating figures? And I think the overall point that I'm trying to convey with this is that we're showing you the basic figures and how to make them in Python, but the best figure for your research is always going to be the one that allows you to tell your story, the story of your data as clearly as possible and with as much detail as possible without being confusing or overwhelming for the viewer. So like I said, it's a bit of an art that you will improve with over time. Any questions? No? Okay. So next, I'll just introduce the different Python libraries that we have available to us. So we already have used matplotlib and Seaborn a couple times, but matplotlib is very easy to use. It's a built-in data visualization packet or library in Python, and it's based on the NumPy arrays. So there's tons of options, tons of different types of plots that you can make in matplotlib, like scatter plots, line plots, histograms, etc. There's a lot of flexibility with matplotlib. It allows you to change a lot of the features of how your figures look. And it's very customizable and it's very well documented too, so you can understand what all the options are for customizing your plots. Seaborn, as I said, is kind of what makes your plots more aesthetically appealing. It's a high-level interface that is built on top of matplotlib, and it really focuses on creating beautiful figures and with lots of different color palettes available to you and some nice stylizing, so you have a little bit more visually appealing plot. Seaborn isn't always the right choice, but sometimes it can be very effective. So Seaborn also has a lot of themes that are built in and is really good for displaying statistical analysis. Okay, so these are the two plots I mentioned earlier that allow you to create interactive plots, which can be really interesting for the user and exciting for you as the researcher to show your data in this way. So one is called Bokeh. It's mainly famous for its interactive charts and visualizations, and it's nice because it can make the legends. You can make the legend interactive, so you can select. In this example here, you can select which type of data you want to see or not see, so you can maybe turn off some data that you're not interested in looking at that time. Then there's also Plotly. Plotly has hover tool capabilities that allow us to look at outliers or anomalies, and you're looking at a lot of data, so there's a lot of customization with Plotly. And again, it makes a visually attractive graph. So Plotly lets you create drop-down menus for your figures, so you can show just a subset similar a little bit to this option on with Bokeh, where you're selecting only um, one data point or data set from the legend, but scatterplot. Here we have like you can select to look like a scatter plot, a bar plot. You can create drop-down menus to sort of customize on the fly to allow your users to customize on the fly your plots. And then on the right here, we see a hover tool, so you can, with Plotly, create figures where the users can hover over the data points with their cursor, and then it will have a little box pop up that will tell them exactly what the what the value of the data is at that point, basically. So we're not going to create any plots today with Boca or Plotly, but I just wanted to introduce them to you. So if you have an interest or a need to create an interactive chart, you are able to do so. So let's open up Python. Because any questions actually before we carry on? No? Okay. We have only 2 activities for the data visualization section. So let's open up activity 1. Okay, so this exercise is just essentially going to load in a data set and go through and make a bunch of different types of plots with it. So first we will download the data. We will import matplotlib, pandas, and seaborn. So we've already used matplotlib a few times where we call functions from it using plt. Seaborn is more common to use SNS. So I have no idea where the S at the end comes from, but that's what it's commonly called, referred to. So Seaborn is usually imported as SNS to give us that nice short handle for using it. So we've downloaded the file. We have called in our libraries that we'll use, and let's read in the data file, which we've done multiple times now. So hopefully you're comfortable with these first couple steps. We can read in the data frame and take a look at it. So this, we have a separate column for day, month, and then we have place 1 and place 2, which are which we've kind of been working with all day. These are temperature values from 2 different places. So the first plot we will make is a line plot. So we can assign names to the data in the file. So these are similar to what we've been doing, where sometimes it's preferable to assign a variable to a column in our data frame. So here we're calling out place 1, place 2, and then the date, which is going to be the day column. So we have data from 366 days. This is a leap year, so it has an extra day in it. So we can just use the plt.plot function to plot line graphs. It'll do it automatically. So we have 2 here where we're plotting place 1, and then on the same axes, we're going to plot place 2. So once you plot that, you need to make sure that you're labeling your X and Y axes in order to make sure that people can understand what your data actually is. So plt.xlabel to put day on your X axis, and then plt.ylabel to put the temperature on the Y axis. You can add a plot title, temperature variation. You can add your plot legend through plt.legend. And as I think it was Joelle who asked earlier about moving around your legend, you can do that with the LOC call. So in this case, LOC equals upper left. It'll put our legend in the upper left. So all of these things, when you see what like loc, there are lots of different sort of options that you can put in there. Matplotlib legend. So you can always open up the documentation for the tool that you're using. So this is matplotlib pyplot legend, and there'll be lots of different arguments that you can put in here. And there's always going to be a description of all the different options. So you can look at all of these to see what you might want to put in. So um, yeah, there's just there's tons, right? So you can pick the location, and it will tell you all the options you can put in for your location, center best, center right. It'll tell you, you can anchor it. You can change the number of columns to show maybe 2 columns of your legend will have 2 columns. There's, changed font size, label color, number of points, scatter points. So tons of different options for this legend to make it look exactly how you want it to look. And we're not going to go through all of these today in any case, but I'm just showing you this so that you can, whenever you are creating or working with Matplotlib or any library um, in Python, you can usually find a website, a page somewhat like this, where it will go through and it will explain all your different options for how to change um, the appearance of your figure. And I just found this by searching matplotlib legend, and it was the first one that came up. Okay, so little side path. Okay, so that is plt.legend, and then we are also going to save the figure because maybe we want to use it in a presentation, in a paper, or whatnot. So we want to have access to it outside of Python. So you can do that with plt.save figure, give it a title, whatever you want, and the format that you want to save it in, JPEG in this case. Also, you can tell it JPEG here, and then DPI. This is stands for dots. I think it's dots per inch. Am I making that up? Dots per inch, DPI. But basically, the higher the number you use, the higher resolution your figure is. So I think for print publications, usually you use DPI of 600. It will take up more memory on your computer, but it's a higher quality figure, right? Um, but I would say you can use anything from like 96 up to whatever you want, but 96 is like the lowest quality figure that I would recommend using, and that would only be kind of for personal use, not something that you would share with the public. But it would show you what you need to show. It just wouldn't look as nice. So I guess we can play with this. Let's run it so we can look at our figure. And you wouldn't be able to see any difference if I changed the DPI right here in Python, but if you saved it, change the DPI and you save it, you would see that difference. Okay, so this is just all the default settings on with this figure, but you can also, in addition to changing anything and everything you want pretty much about the legend, you can also change the appearance of the figure. So you can change the way the line colors are, the color of the lines, right? So you do that just by changing, adding this color equals R for red at the end, or comma color equals G for green at the end. Uh, there's a wide number of colors that you have available to you, color codes. There's a couple listed here, G for green, K for black, W for white, etc. This is again something that you could Google and find. Google and find all the color codes. What's really nice is that you can also put in a series of 3 numbers here for the RGB, like the RGB values basically, and so it can literally create any color that you want. You do not have to stick to this red, green, black. You can put any color code you want in here, um, and it will give you that right color. So there's tons of options for um, making these kind of graphs your own and making them look the way you want. So here now you can see we have red and green lines. Similarly, you can change with our next cell, you can change the line width um, and the line type, which we will see next. So here we're making one of the lines really, really thick by giving it a line width of 4, and we're making the other line width really narrow by giving it a line width of 0.5. And I'm not sure there are limits to these numbers. I've never reached the limits of these numbers. Maybe at least there's probably a lower limit, but you can make them as thick or narrow as you want. So we can see we have a really thick line on the bottom and a really narrow line on the top. Okay, so next you can also change the line style. Again, something that would be Googled, so you can find all the various options. But here we're just adding comma line style solid and comma line style dashed to see how that changes our figure. So here we have now a solid line and a dashed line. And we can. Any questions on this so far? Are you all able to run these and see these changes happen and kind of understand what's causing the changes? Yeah? Okay. So you can also change the font size, which is great news. Um, if you do that, you can change the font size in a couple different places, but one of the easy ways to do it is to just add comma font size to anything that is going to be a text element basically. So our X and Y labels, we can increase the font size by adding comma font size equal to, for in this case, 15. You can increase the font size of the title of the plot and also of the legend, and also of the tick marks, right? So the labels for the X and Y ticks as well. So you can pretty much do whatever you want in terms of making this fit. So this might be a good example of using one of our legend location options. So we see here that I increased the font size to 15, but now my legend is overlapping my data, which is not a good idea in my opinion. So we can go to best. Best is one of the options that Python allows Python to put the legend wherever it thinks is best to make sure that it doesn't overlap the data or doesn't interrupt, your data. Sometimes it will still happen, but it's an option. So let's try to replace this upper left with best and see if it picks the same thing or something that we like more. Okay, so now we have our legend on the bottom center, lower center, and it's not overlapping any of our data. It's a little bit of a weird place when you're talking about data. You don't often see legends right in the middle on the bottom, but in this case, that's where it needed to be to not overlap the data. Okay, so you can also change the axis limits to your figure, similar to what you might do in Excel. So this, with this figure here, is just automatically set whatever Python thinks is the best limits based on the limits of your data. But maybe you want to zoom in on your data in one area, or you want to cut off part of it for some reason. You can also change your axis limits. So um, the only thing that's sort of new here is the setting the axis limits. So the code for this is plt dot xlim, and then you put in these square brackets the lower and the upper limit that you want to see for the x-axis, 25 to 50, and you can do the same for 10 to 30 on the y-axis. So this just shows you one portion of your figure. So if we're looking at 25 to 50, and then 10 to 30, so we're looking at this portion of our plot right here. I might change this a little bit. And there, so then you get a little bit more, a little bit where you can see the whole bottom line. And it's just a way to zoom in on your data. If you were really interested to see temperature variation, between day 25 and 50, you could do that in this way. Any questions? Okay, so we already did this a little bit, but um, for more detailed information on any of these sort of arguments and their values, you can come here and look at all of the different options, and also gives you some instructions on how to use the figure. So this will show you yeah, pretty much anything you want in terms of the different properties of using the plot tool in Python. So the options are not endless, but fairly close to endless. It's pretty much everything that you would need for a standard plot. Okay, so um, next we will talk about how to use Seaborn, which is very similar to Python or similar to Matplotlib in terms of how it is used, because they are Seaborn is built upon Matplotlib. So a lot of this looks almost exactly the same. The only difference is this: we're using sns.lineplot to make our line plot. And here we have our x value is equal to day, our y value is equal to place, and then here we're telling Seaborn which data frame to use as our data source. Right, so in this case, we're using the DF data frame. So this looks a little bit different from what we did here with our earlier plot with Matplotlib. So what's down here in this bottom half, this is all the same, just labeling our x and y axis, labeling, telling the legend what we want our labels to be, and then titling the plot. So this is one thing that you might be interested in doing in the future. So maybe I don't want to change all my variables in my data, but I know that place one is, for example, I don't know, Vancouver. So I can just change, instead of changing anywhere else, that place one is Vancouver, and then maybe place two is like Arusha or something. And so you can just change those automatically, and it changes only the way they're labeled in the legend. So you don't have to go back in your data and say, hey, place one is actually Vancouver, place two is Arusha. You just do it right here, and it comes up automatically in your legend. So it's a quick and easy way to change how it's actually shown. And it's nice because you don't use spaces when you're labeling variables, but you can use spaces when you have titles like this. So it's nice. Any questions on that? Note that this is a matplotlib function. It's not. You can do this in matplotlib or Seaborn. It's not required to use Seaborn to do change your label names. One thing that Matplotlib does let you do is to change the colors of your data based on sort of categories of it, right? So in this case, we are building a figure with the temperature variation over time, but maybe we want to see how the temperature varies just within different months, right? So we can add the argument hue is equal to month, and it will color your figure, your line plot, based on which month those data, um, which month that data is associated with. And then you can pick a bunch of different palettes, but this palette chosen here is dark, and the palette is just another word for, which set of colors will be used to apply or to create this figure, basically. So here we have a figure where each month is a different color, and this color is selected from the dark palette. And we have our labels for X and Y axis and the legend and the title. Okay, so I mentioned that this palette is just which set of colors you want to use. Um, so you can find a bunch of different color palettes here. So if you click on it, you can find which one you want. Okay, so anybody want to pick a color palette? Which one should we use? If you open it up, which one do you like? Spectral. Okay, let's see. I hope, is this lowercase s? Maybe I should find it on here. Spectral. No, it is uppercase. Good thing I looked. So we can, just find this and copy it in and um, here, I'll put it here to see how it changes our answer, our result. So this is another way we can do a little bit more visually appealing, in my opinion, than the dark, but a little bit also harder to see the difference, the specific difference in the month. So thank you, Sydney. Yes, spectral is a good choice. Okay, so if you don't want to open up this color palette and look at it, you can also force Python to show you what the color palettes are. So in this case, this is the same example, but instead we've put the name of a palette that does not exist. And so when you run a bit of code that doesn't function properly, that there's an error in, sometimes Python will pull up some information that will help you solve your error. So in this case, they're telling you in this error that paired is not a valid palette name down at the bottom. So you can scroll up here and it actually tells you what the list of potential supported values are for that, the right answers that can be chosen. So you can pick any one of these codes. I don't even know how many there are, a lot. And put that in and it will work. So for example, I don't know, twilight shifted. I don't know what to expect with twilight shifted, but we can replace this and run it, and we should get an answer that works. So that's just one way to get all of the possible options without going to look at a different website if you wanted. But this way you don't really know what they look like. One thing that I wanted to bring up here, oh, I closed, nope, is that there is sort of increasing recognition in the scientific community that when you do create figures that a lot of, people are colorblind, right? So creating colorblind friendly figures is a big issue, and something that you should do just as to, help out your fellow scientists and engineers so that they don't have trouble figuring out what you wrote just because the colors, their eyes can't see the colors. So there is a tool in, there's a couple tools, but ways to options for creating colorblind friendly palettes in Python, and knowing which website to, not which website, which palette to use to make sure that it is colorblind friendly. So there's a colorblind friendly colorblind friendliness simulator which you can use, which is kind of interesting, even if you're not colorblind, to kind of see what colorblind people, how they see things. So this is pretty cool because you can load up one of your figures into this website through this choose file. Sure, why not? This is open. We'll load this. And then you can see for different people what this looks like, by clicking through these, these are all different types of color blindness, basically. So you can see whether or not the figure that you created is going to be able to be read by someone who is colorblind. So it's a pretty easy way to verify that your figures are readable. So this is the COBLIS colorblindness simulator. But this is, I think, also a really interesting article as well from Towards Data Science about creating colorblind friendly visualizations. Okay. Any questions on that? Or on what we've talked about so far? No? Okay. So this is just an example where we chose hot from the list of potential values here. So we can just run this and look at what the hot palette looks like. It's ranges from like a dark red to yellow. So it's doing the same thing as before. So next, those are a bunch of line plots, right? Lots of basic information shared about line plots, most of which can actually be applied to every single type of plot plotted in with Matplotlib or Seaborn. They have a lot of the same options and arguments, just the style of the plot will be different. So to create a scatter plot, we use plt.scatter. And again, we're using the same arguments that we did with a line plot, the same labeling and titling of the axis and the legend. And here we're saving it as a scatter plot, saving the scatter plot again. So similar to with the line plot, you can change the marker labels, or the marker types, the marker colors, the marker size. There's all sorts of options available to you here for making this figure look the way you want it to look, to make sure that your data can be seen. So you can also make a scatter plot using Seaborn, which this is a little bit hard to see, but here we have we've created the scatter plot with Seaborn, so using the sns.scatterplot function, where we have pretty much the same arguments as before with a line plot. And again, we've chosen to use the style function as month to call out, or so that every month will have a different marker. So it's a little bit hard to see here, but if you look at the legend, you can see that all the circles are from month 1, so on and so forth. You probably would want to also apply a hue to this as well to make sure that you could visually discern it better. Okay, so we can also make a bar graph. So this width will be used to call out how wide every bar is going to be in your figure. It's a easy way to change the appearance of your bar plot. We're plotting bar plots with plt.bar. We have kind of our at this point, very standard arguments, and we're just the one that we're changing or adding is the width. We're setting the width here to 0.2. And then we have the same labeling, always labeling your X and Y axis, a title, the legend, and then again, saving our figure. So this is what our bar plot looks like with these settings that we've had, and then with a width of 0.2. So just to show an example, if I were to increase this to 0.5, how it might look. And so now they're very thick bars. We could even see what happens if we increase it to 1.5. Now they're too thick to see, they're blocking each other out. So one of the things that we haven't covered is there are ways to increase the size of the figures or to set specifically the size of the figures that are made so that you can see the data if you need to make it bigger. So the next kind of option that we'll look at, so this is a standard bar plot where every bar is right next to each other. But you can also, which is sometimes useful, to create a stack chart. And the only thing that changes here is to tell you're telling Python to put the place 2 data on the bottom of place 1. Or wait, no, that's the opposite. So you're putting place 2, and beneath it on the bottom of place 2 is place 1. This is backwards of what I said initially. So if you run this, you can see that place 2 bars are on top of the place 1 bars. And so sometimes this is useful to see trends in the data. Any questions on scatter plots or bar plots? Like I said, a lot of this, in terms of the arguments that you'll use, are very similar. It's the biggest thing that will change is which type of chart you're using, whether it's bar, scatter, line. And with each type of plot, you'll have slightly different options available to you. Maybe some little bit more details. So you can also make a histogram with matplotlib. This is an automatically generated histogram, but you can also specify the number of bins, the size of the bins, all the different colors that you want. So this is a histogram for the temperature at place 1. You can see you kind of have this is like a bimodal distribution of temperature. So we have a lot of days where the temperature is pretty cold, with it being between like about 10 to 15 degrees. And then we have a lot of days where the temperature is really warm, like up around 30 degrees, and only a few moderate days of temperature, if you will. So this is a histogram. I would say this is the first really obvious point where Seaborn makes things look a little bit nicer. So here, if we can plot the histogram using Seaborn, using sns.histplot. So instead of hist, which we used with matplotlib, we're using histplot for Seaborn. And then you can use the data.df, or data equals df, the initial data frame that we used, and then we're giving a title to telling it what to use for the x-axis. And we're labeling the x-axis as well. So this one looks to me a little bit more visually appealing. It's just a little bit nicer color, not quite so, I don't know if I want to say like harsh on the eyes, but it's a little bit um, softer color blue, and then it has the nice outline on the bars. So this allows you to also change the number of bins. So with histograms, bins are essentially how wide each of the bars are. So um, if you do not specify the number of bins, they will kind of calculate automatically for you what they think is the ideal. But if you want more or fewer bins, you can tell it the number of bins, and it'll have smaller ranges essentially for each of the bars in the histogram. So instead of having bars that are, it's kind of hard to tell, but maybe like 3 degrees wide, it now looks like we have bars that are probably like 1.5 degrees wide, or bins that are like 1.5 degrees wide. So now we have 20 bins, and you can see that there's a lot more definition in the plot. So that's just done with the comma bins function. Okay, so next we have box plots. This is again very similar to what we have seen before, but now we are using the box plot function in the Seaborn package. And so we have Seaborn.boxplot. We have y is equal to place 1. This is what we are plotting, right? And so we are just then labeling our axes, and we can run it, and we get a standard box plot here with just one box plot on our axes. But usually when we're making box plots, we don't want just one box plot. We want to have multiple box plots to compare and see how things are changing. So we can do that really easily, especially with Seaborn. So we have sns.boxplot, where we have, we're telling it which x-axis to use. So this is what, for each value in the x-axis, we'll create a different box plot. So we're using month here. So there's 12 months of the year, we'll get 12 different box plots. And for our y value, we're still using the temperature at place 1. Palette chosen here is blues. You can pick any, spectral, still an option. And then we're just labeling the x and y axes. So here we have a nice box plot where we have one box for every month, and we can see how the temperature is varying over the year. So just for fun, we can run this with spectral as well and see how it looks with different palettes, because why not? One of the ones that is supposed to be really colorblind friendly is called Viridis. Nope, I clearly got that wrong. Not Viridis. Hold on. Oh, now I'm not going to be able to find it. Oh, it's a lowercase v. Okay, my bad. Okay, so this is also one of the other options that I think for this range of data might not be the best choice, but is usually good for geospatial data. Okay, what have I done? Blues. Uppercase B. Okay, we're back to where we were. Cool. Okay, so we can also create a box plot for, so this is the box plot just for all the data, temperature data at place 1, but split it by every month, but maybe we want a box plot that allows us to easily compare the data from month 2, or not month 2, but place 1 to place 2. We can do that as well because we still have that data in our um, initial data frame here. So we can make a box plot for place 1 and place 2. So for this, we are creating a smaller box plot because we don't want to include day and month in our box plot. We only want place 1 and place 2. So we're going to use df.drop. We're dropping the day and the month columns, and we're telling it these are the columns that we're dropping using this axis1 argument. So we can use sns.boxplot data equals x1. So we're telling it to use for the data the variable we just used, and then we can again label x and y axes and plot, run this cell, and we see that we have a box plot for place 1 and place 2, and it makes it really easy to see that place 2 is definitely generally warmer than place 1, and that place 2 has the temperature skewed high, basically, because the higher than place 1. So it means that place 2 is more likely to have more hot days, whereas place 1 maybe has more hot and cool days at the same time. So those are box plots. So you can see also, if you wanted to just look at the smaller data frame, you could, and compare it with the original data frame. But remember, we dropped these day and month columns. Okay, so any questions on box plots? So as with all the other types of plots we've talked about, there are a lot of arguments that you can use to make these look, however you want. But the important kind of pieces are always making sure that your plots are readable, so that the text, the font size used for the plots is something that people can read at a normal, like 100% zoom level, and then also making sure that the colors, um, that everybody can see and read your data. So talking about the colors that you use, the line weights that you use, the resolution that you use when you export it. You don't want your figures to be blurry, right? So use a high resolution. These are all things that will help you make sure that the plots you create are good. Okay, so last step is creating the violin plot. So this is another Seaborn type of plot. So it's just sns.violin plot. And for this, we are using y equals place 1. So we are creating a violin plot for the temperature at place 1. And again, we're just labeling the x and y axes. So we can see here, our violin plot is very similar in terms of having a lot of data here centered around like about 30 or so. And then another chunk of data centered around 10 to 15. This pattern that we've seen for place 1 has been evident throughout. So we have, it's a little bit harder to see in the box plot, but let's go back to our histogram. So here we have our histograms where we saw a bulk of data around 10 to 15 and then another around 30. So the same shape that we had from our histogram comes up in our violin plot. So similar to the box plots, you can set it up so it set your violin plot up so that it makes a different violin plot for every month using just the x equals the month variable of the month column of the data frame, y equals the place value of the data frame, and then we're again using our blues palette. So if you run that, you will get a different violin plot for every month. And you can see really easily how the distribution of temperature values vary throughout every single month. So we kind of have the winter months and then the spring months where temperatures are increasing, but there's a lot of variety, and then it gets warm and stays warm, starts to cool down again. So you can see that really clearly with the violin plot. So violin plots also, as with all of this, have a lot of options in them. So here we have the sort of default is to have a box plot essentially in the middle of every single violin plot. But sometimes, especially when you're creating a bunch of violin plots like this, it actually makes it hard to see and doesn't, in my opinion, add a ton of value to have the whole box plot in there. So there are a bunch of arguments that you can add to change the appearance of your box plot. So for example, here we have added just inner, meaning on the inside of the box plot, what do we want? And we use the argument none. So we run this and it takes out those mini box plots in the middle. So then we see that it's a little bit easier to see the distributions, but then we don't have the little dots in the middle like this that show you where the average is. So whether or not you want that, it's up to you. And there are, in addition to completely removing the box plots, there's a number of ways that you can change how the box plot in the violin plot looks to make it take up a little bit less space. Okay, so the very last thing before we take a break will be to make a violin plot for place 1 and place 2. So we are again going to drop the day and the month variables, our columns, sorry, from our initial data frame. And we're going to tell them they are columns with our axis 1. In place equals true means that we're going to actually change the DF data frame itself instead of creating a new data frame as a result of this. So before, when we used drop day and month, we assigned it to a new data frame and we did not use the drop in place so that we maintained access to our whole data frame. But here we are going to drop the day and month columns from our initial data frame. So then when we do that, we can just use sns.violinplot to set our data frame, our data equal to our data frame, and plot that, and it should just show you only the day and the month. And just for the sake of showing you, oops, there it goes. Okay, I can then look at DF and see that the day and month have been dropped from DF itself as a result of this in place equals true, instead of creating a new data frame with only this information in it. Okay, I know that was a lot of different plots, but hopefully you learned a little bit about what what's possible, and then also kind of understand based on our discussion during the lecture portion that these are the basic tools, the building blocks that you can use to create great figures. That sometimes basic plots will be what you need to convey your information. Sometimes you might need something a little bit more involved, but it comes down to what story you're trying to tell about your data and making sure that your figures are created in such a way that that story is very clear for your audience. Any questions? No? Okay. So let's take a 15-minute break to stretch our legs a little bit, and then we will come back here um, at like 3:10 or so. Yeah, let's come back about 3:10 and we will finish this up. I think we have only one more activity, which is much shorter than this, so we might end a little bit early today. But I will see you in about 15 minutes. Thanks, folks. Hey, folks, so it is 3:10, so let's get this back underway. Hopefully you are all back from your break. Um, if you have not already, please go to the My GeoHub course page and under Data Visualization, Jupyter Notebooks, open up Activity 2. So if you haven't done that already, I'll give you a few moments since I know Jupyter Notebook can be pretty slow to open sometimes. And if you are having problems running Jupyter Notebook through My GeoHub, it does hang up a lot if you have too many instances of Jupyter Notebook open. So you can always go check how many sessions you have running from going up to your name and clicking on the dashboard. And you can see, for example, I only have one session running. If you have a bunch running, you can terminate them and you should be able to run a little bit smoother. And you can also terminate your sessions up here in the top right corner. Okay, so the point of this activity is essentially to show you how to, or to show you that you can combine for loops with plotting in order to essentially auto generate a bunch of figures all at once. This is incredibly time saving if you ever need to do it, and can just be really helpful. And one of the really cool things about Python, which you may or may not have need to do sometime, is that you can create a series of figures and you make a for loop, create the series of figures automatically, and then you can also use Python to turn it into a video by essentially stitching together all of your JPEGs or your PNGs or whatever you choose to save it as. So you can create essentially research videos that way, which is really an effective tool when you're sharing your research with an audience. So this is one of the steps that you would do to do that. Okay, so for creating multiple plots at the same time, we're going to download the data that we're going to use. Then we're going to import the three libraries that we've been using so far today: Matplotlib, Seaborn, and Pandas. I should say this afternoon. And then we are going to, again, load our Excel file. And we can look at the data frame that we set it equal to. So here we have 119, or sorry, 114 rows of data for 8 different places, place 1 through 8. And what we can do here is we are going to first show you how to, for every so for every instance, 1 through 8, we're going to add a line showing the temperature variation for each of these places over each day of the year. So we're using a for loop here to plot essentially all of these lines onto this figure at the same time. So we have for each I in range from 0 to 8, we're iterating 8 times. We're going to find the column that we're interested in using this call. So this is all of the rows, and then this column right here, so I plus 1. So initially I is going to be 0, and then we will call I plus 1, and it will increase every time we run this to 0, 1, 2, 3, 4. So we'll be getting, we'll start out getting place 1, then place 2, then place 3 through this index, which is increasing in size every time this for loop is run, essentially. So we're getting each column, and then we're getting the x value, setting the x value equal to the day column of the data frame right here. And then we are plotting it, right? So we're plotting x, y label. So this is what the variable will be called in the legend, or what the plot, kind of the name that the plot has for this data set. So it's nice that with for loops you can actually create a dynamic label name. So we have place plus string. This str is going to make a string, and the string will be whatever I plus 1 is. So in our instance, it'll be 1, 2, 3, 4, so on and so forth, which is what we also used the I plus 1 here in calling out our data column. So then we're going to go through and add our X and Y labels and then add the legend. So you would be able to add your labels after, like outside of the for loop. So in this case, you're adding the labels 8 times, which is not necessary. So you could put your labels outside of the axis. It would be a little bit more computationally efficient to do that. So once we do that, it'll go through and it'll increase I to plot the next column, then the next column, so on and so forth. And then once we plotted all 8 columns, we'll be done creating the figure and we can save the figure, which it does here. So we can run this and see that we have a figure with a bunch of different lines on it. It's not super easy to see every line individually, but every line is a different color and they're all there, which we can see from the labels. So this is just one instance of how you can use a for loop to plot each, or to plot multiple lines on a figure without having to go through and plot them individually. And so, like I said, if I was going to do this, I would probably um, put the labels on outside of the for loop, so we only did it one time. It won't visually change anything, but it would be a little bit quicker, quicker to run. Any questions on using a for loop to plot plot a bunch of lines from a data frame? Okay, so the next one that we will go through is how to create a bunch of different figures. So instead of putting all 8 lines on one plot, we will use a for loop to create 8 different plots, which each plot has one line on it, being place 1, place 2, place 3 on each of these different lines, or each of these different plots. So this is fairly similar. Oh, sorry, I didn't realize I skipped ahead. Hold on a sec. So let's back it up. We already talked about this a little bit, but this is showing you how to change the legend location. So um, here we have, instead of putting the legend just in the upper left corner, which is covering a little bit of our data, we can change where the location or the legend is located by using number of columns is 5, and then we did indicate that the font size was 0. We still have a little bit of data overlap here, which we can change by changing the limits of our x-axis. So here we have our data in 5 columns, or not our legend labels in 5 columns, 1, 2, 3, 4, 5. And so it is a little bit easier in this case to adjust the limits of our axes without interfering with our columns. So we should be able to just do plt dot ylim, and let's see. So we want to go from Sure. Let's do like -5. That looks like it's about what it is. And I can't tell what that is, but we can try. Maybe like 300. See if that works. Okay. So yeah, now our y limit is all the way up to 300, and we can see that our legend no longer is overlapping our data. So whenever you're making plots, you're always going to have to make these small adjustments to make it fit and make it look the way you want. But what's nice is once you kind of get this figured out, you can go in and you can change the data frame that you're using, and it'll remake the plot, again as many times as you want. Okay, so that is how you can change how the legend looks basically by changing the number of columns. You can also change the number of rows if you wanted to, but columns is kind of the more common way it's done. Okay, so this is what I had started to introduce earlier, where you can use for loops to plot every single place individually, like what we see here. So we have one plot for place one plot for place two, place three, place four, if we had reason to plot them all individually and wanted to do that. This would be maybe really common for uh, if you're using geospatial data and plotting a time series of geospatial data, which would be basically what you could turn into a video, which is really nice. Or you might have like this, where you want plots for a bunch of different locations. You don't want to go through and make each plot separately. You can put it in a for loop and it will create it for you. So here again, we have 8 different places. So we're doing our for loop for I in range of 8. And then we have the same y variable and x variables as before, where our y is finding the first column in our data frame that has temperature values in it, and then it goes just +1 to go to the next one, next one, next one, every time this for loop is ran. So then we plot it, again, the same way as we did before, same labeling. The only difference here is that we are saving. I guess there's 2 differences. We are saving, we didn't save them, okay, but you could save your figure inside of your for loop. And so every time you run your for loop, you're going to save that figure again, a new figure again, basically. So you can dynamically create multiple saved legend figures, not saved plots at the same time. And then if you're running this for loop, you want to, if you want to create a new figure for every single time the loop runs, you'll have to clear the figure using this plt dot clear figure function right here, CLF. If you don't have this line, you don't have this line inside your for loop, it will keep plotting this data on the same set of axes, which we don't want if we're trying to put them on separate ones. So we can run this and see we now have 8 plots with our rainfall values over time. Okay, we can very similarly do nearly the same thing for where instead of creating multiple line plots, we're creating multiple bar plots, right? So this is essentially the same, except we have replaced plot with dot bar, but everything else is the same. And so we are again creating a bunch of different bar plots all at once. And we're having the plt.clf function in here to make sure that we are clearing that that first figure to make a new figure every single time, instead of re-adding the data to that same figure multiple times. So basically getting a new set of axes. So if we run this, we see we now have bar plots of everything, and you can do this with any type of plot that you want. And it doesn't always have to be a matplotlib. It's any plot you want to create multiple plots at the same time. You can just plop them into a for loop, and it will run it all for you pretty easily, pretty quickly. And again, you could choose to save these each figure if you wanted to have access to them later outside of Python. Okay, any questions on creating multiple bar graphs or multiple line plots at the same time? No? Okay. There is an activity for you to work on. Sorry, doing a lot of talking today. My voice is a bit raw. Um, where you can try to create a scatter plot for each place. So this is a separate scatter plot for each place, which would be very similar to creating this multiple bar graphs, except you're going to use a scatter plot instead of a bar plot. And then also to create one stack chart for all places. So if you remember in activity 1, the stack chart was created from the bar chart, except you would have to put bottom, which value you wanted on the bottom, basically. So let's take a few minutes to work on this, and then we will reconvene. But of course, I'll still be here if you have questions in the interim. How are we doing with this activity? How many have been able to create the scatter plot so far? Scatter plots, I should say. The stack chart is a bar chart, not a scatter plot, if that's what you're asking. So the create one stack chart for all places is you're creating one, you're welcome, um, stack chart, stack chart, which is a type of bar chart with all 8 sets of data, and then the scatter plot is you're being asked to create 8 separate scatter plots similar to the 8 bar charts that we created and 8 line plots that we created. So I will give you a hint with the stack chart, which is the type of bar chart that Python automatically, if you are plotting multiple data sets onto a single bar chart, Python automatically makes it a stacked chart. You have to do a little bit of extra work behind the curtain in order to group your data together, um, and have all the bar charts side by side, all the bars side by sides. But that's not really a practical thing to do in this case because you would have then, for example, like 8 bars for day 1, 8 bars for day 2, 8 bars for day 3. So this is not really an example where you would actually want to group your bars together for a bar chart. So Python will automatically create a stacked bar plot for you, where it will stack, all of data 1, all of data 2, all of data 3 for each day of the year. All right, so has anybody had success completing both the scatter plot and the bar plot for the activity? If not, that's okay. Because I know some of you are fairly new to Python and may not have experience with Matplotlib or experience with working with for loops. And for loops, can be a little bit difficult until you understand how they work. So I will show you how to do this. Um, it's pretty straightforward. I am, to make this easy for myself, just going to copy and paste the code we use to make the multiple bar graphs here, except I am going to make it a scatter plot. So all I'm going to do is change this bar to scatter, and I think that should be all we need to do. Yeah, it looks like everything else is there. So there we go. So all I did was copy the text for the bar plot, pasted it down in this cell, and changed bar to scatter, ran it, and we now have um, one scatter plot of rainfall over throughout the year for, I guess this is only the first 114 days, but for each location. 8 figures there, and then let's highlight this, press B to get a new cell under here, and we can very similarly create 8 bar plots. So let's use our line plot function that we used earlier for this to make this one a little bit easier. So this line plot is what we used, this line plot text is what we used to put 8 lines onto one figure, right? So we're going to use the same one to create a stacked bar chart with all 8 sets of data on one set of figures. So here, the only difference we're going to make is to change this plot into bar, and that should be all we really need to get all 8 of our bar plots on one set of axes. We run it, and that is what we get. This is not super easy to see in this format, but we have um, all 8 of our data sets listed here, and we can see pretty clearly that they are stacked one on top of each other. So if we wanted to make it a little bit easier to see, I might change this 8 here in my range 1 through 8. I might change it to 3, and then I'm only plotting 3 different data sets. And it'll be a little bit smaller, a little bit easier to see. And instead of maybe plotting all of my data, maybe I only want to plot like the first 20 days or something. So it'll give me a little bit bigger bar. So instead of plotting all of the days of data here in my df.ilook, I can do 0 to 20 or something, and then maybe not. That's unusual. Let's try this. Nope, still doesn't like it. Okay, that's not working for some reason. But you can, instead of maybe doing it that way, you can make a subset of your data frame and then plot all the rows, all the columns again, and it would achieve the same thing. I was just trying to cut down the data plotted to make it a little bit easier to see. But we can see that by changing from range 8 down to range 3, we took off 5 of the data sets, and we're able to see a little bit more clearly the difference between the data sets. Okay, so that is how to plot all 8 of the data sets on a single axes in a stacked bar chart style. Any questions on this? Was there anybody who was not able to achieve this? No? Okay. If nobody has any questions and we are all happy with kind of where we've gotten to today, this is all I have for you. Tomorrow morning, Dr. Park will pick it up with the machine learning content, and then we will end the day a little bit early talking, not talking, but with a little bit of a closing discussion, and also ask you to complete the both kind of conceptual post bootcamp survey and then also the more experiential post bootcamp survey, um, which will be a lot of the questions will be questions you've gotten used to seeing now through the pre-surveys. But without further ado, I will see you all tomorrow at the after the machine learning content is finished. But thanks for your attention today and going through all these various activities with me. I will see you tomorrow.